Hello everyone, in this video we will discuss the multiple choice question, that is the objective type questions from the class 12th chemistry chapter coordination compound. In the CBSE exam, the weightage of this chapter is almost 7 marks, which means from this chapter the question of 1 mark, 2 mark, 3 mark, 4 mark question can be easily asked. Now what type of 1 mark question can be framed from this chapter? In this video we will discuss that. So the first question here is the oxidation of nickel in NiCO4. Now this complex is, we can say, since no charge is present over it, which means it is a neutral complex, and carbonyl is also a neutral ligand, so that there will be no charge on the ligand, so answer will be 0 here. Now the next question here is, which of the following will give a white precipitate on reacting with AgNO3? Now this question is based on the concept that a coordination compound contain a coordination sphere and a counter ion, which means it is a ionizable. Now on ionization it produces a ion which can easily react with AgNO3. Now as we know, AgNO3 is used in case of halogens. It react with halogens and form the AgCl or AgBr or AgI depending upon the halogen which is available. Now in all these examples, whenever or wherever that halogen is available for ionization will give the precipitate. Now in the first case, if it will be ionized, it will be giving 2K plus and the coordination sphere here. In the second case, there will be no ionization because there is only a one coordination sphere is present. In the third case, it ionized to produce this positive complex and 3 chloride ion. And in the last case also it does not ionize because there is no ion present or a counter ion present here. So only in the third case it is releasing the Cl minus ion, which means the AgNO3 will be precipitate in the form of AgCl, which is white in color. So option third is the correct one. So this type of a question is easily framed in coordination where a complex is given to you. Now for example, if instead of Cl, SO4 will be there, then they will give that it reacts with BaCl to give a white precipitate. Now we know that barium sulfate is a white precipitate. So in that case, the sulfate which is present outside the coordination sphere will give this test positive here. So this is the second type of a question which is framed from the coordination chapter, and this is even asked in the CBSE 2020 exam set to Delhi. The next type of a question in the coordination compound, that you are given the name of the compound and now you have to frame the formula for this name. Now the important point is that it is a triamine, which means the ligand here present is one ammonia, and tri means the 3 ammonia are attached to the metal atom. Next one is trinitrito O. Nitrito O is an ambidentate ligand, that is NO2. So when it is attached from O side, it is written as nitrito O, which means it is ONO. Then it is nitrito O. Now it is a 3, that is tri. So the triamine, trinitrito. Now here it is cobalt. Cobalt is like this. And since it is a plus 3 and we know that NO is minus 1, so it will be minus 3. So overall charge to the cobalt will be plus 3. How? For example, it is X. Ammonia is neutral. NO is minus 1 is equal to 0. So X comes out to be plus 3, which is given here. So for this formula, or we can say for this name, the formula of the coordination will be this: triamine, trinitrito, cobalt 3. The next type of a question here is, how many ions are produced from the complex CONH3 whole 5 Cl and Cl2? So ions are only produced in a complex if it is ionizable. For example, this complex is ionizable. It ionizes into two parts here. One is the coordination sphere, that is CONH3 whole 5 Cl, and these two as 2 Cl minus. So here will be 2 plus. So total ions produced here, 2 here and 1 here. So total will be 3. So option C is the correct answer. So whenever the question asks how many ions produced, you have to just ionize the coordination sphere with its counter ion. Now if it is Cl3, then it will be 3 Cl minus, and overall ions here will be 4. So depending upon how many counter ion in addition to that coordination sphere ion, we have to sum total the both the ions, and the answer will be given in your option. The next type of a question here, you are given the pair of complexes and now you have to identify which type of isomerism they are exhibiting. Now as we know, there are 4 types of isomerism: linkage, hydrate, ionization and coordinate. Now linkage are shown by those coordination compound which contain the ambidentate ligand like this. Now in above example, no ambidentate ligand present, so it can't exhibit the linkage isomerism. Now the second type of isomerism, that is hydrate, will shown by those complex which contain water as an, we can say, ligand here. So also in these two cases no water is present, so that it cannot exhibit the hydrate isomerism. Now the third category is ionization. Now how this isomerism attained? So whenever there is a counter ion which are interchanging their position. Now for example, in the first case, Cl is inside the sphere and Br is outside the sphere, whereas in the second case, Br is inside this coordination sphere and Cl is outside the coordination sphere. So we can say both are having the same molecular formula, but ions are different outside this coordination sphere. So it exhibit ionization isomerism, that is third is the correct answer. Now for the coordinate isomerism, we require two complex compound, or we can say two complex sphere, but here only one sphere is present in one compound. So which means the given example is exhibiting ionization isomerism. The next type of a question here is that we have to find out the coordination number of cobalt in the given complex, that is COEN whole thrice. Now as we know, En is an bidentate ligand, which means if 3 En is present, so coordination will be 3 into 2, because 2 donor sites are present in ethylene diamine, that is CH2, CH2, NH2, NH2. So lone pair present over this NH2 part, which means it has 2 binding site. So if there are 3 atoms, so total 6 binding site or 6 coordination number will be there. So answer C here is the correct answer.